Hello and welcome. Today we are talking about independent events. In probability terms, two events are independent if the probability that one event happens has no effect on the probability of the second event happening. If two events are independent, then two things must be true about the probabilities of those events. The first is that the probability that A and B happen together is the same as probability of A times the probability of B. And the second is that the probability of A given B is the same as probability of A happening on its own. To demonstrate this, let's take the example of a coin being flipped and a die being rolled. In order to determine whether or not these events are independent, we should start by writing down the sample space for the two events. To do this, we will note that the coin can come up as either a heads or a tails, and the die can roll a 1, 2, 3, 4, 5, or 6. So therefore, when we do our sample space of the two events together, we'll use H1 to say that the coin came up heads, the die showed a 1. T3 would represent the die showing a 3 and the coin showing tails, so on and so forth. So if these events are independent, then the probability that the coin lands heads up and the die rolls a 5 should be equal to the probability that the coin lands heads up times the probability that the die rolls a 5. If we start by looking at the events separate from each other, the probability that the coin lands up heads is 6 out of 12 because there's 6 outcomes with an H and 12 in total. The probability that the die lands on a 5 is 2 out of 12 because again there's 2 outcomes that have a 5 out of 12 in total. When we reduce our fractions, we get 1/2 and 1/6. And these numbers make sense because again there's 2 sides of the coin and one of them is H, so I should get 1/2 as my probability for H. And there's 6 outcomes on the die, one of which is a 5, so the probability that the die comes up 5 is 1 out of 6. Using the table, we can see that there's only one outcome with both H and 5. Therefore, the probability that the coin comes up heads and the die rolls a 5 is 1 out of 12. At the same time, if we take the probability of heads times the probability of 5, we would multiply 1/2 and 1/6 to get 1/12, which matches the probability we got off the table, which suggests that the events are independent. We can also prove independence by looking at the conditional probability. So if we want to calculate the probability of H given 5, we limit our sample space to only outcomes that have 5. We then calculate the probability of H using only those outcomes. Thus, the probability of H given 5 is 1/2 because only one of our 2 outcomes with a 5 also has an H. If we compare that to the probability of getting H by itself, we notice that the result is the same. Therefore, the 5 had no effect on the probability of H, thus the two events are independent. So now we can look at a similar example using a contingency table. So once again, we need to prove that the probability of has one pet and flying is equal to the probability of has one pet times flying. We'll start by using the table to get the probabilities of each event separately. So to find the probability of has one pet, we get the total from that row. And to get the probability of flying, we just get the total from that column. The probability of has one pet and flying is 0.075 from this box right here where the two events overlap. If we multiply the probability of has one pet times the probability of flying, we get 0.35 times 0.35, which is about 0.1225. Because these two numbers do not match, the events are not independent. At the same time, if we take the probability of has one pet given flying, we would restrict our sample space to only the first column and then divide 0.075 by 0.35, which would give us about 0.214. This also does not match the probability of has one pet by itself. Therefore, the fact that we restricted our sample space to flying did change the outcome. Regardless of which method we look at, the results are the same. These two events are not independent. And that's all we have for this one. I'll see you guys next time.